Example 4. You can immediately tell example 4 is going to be tougher because there's more than one variable. Okay, there's more than one variable expression. You've got an inverse sine of x and an inverse cosine of x. Let's rewrite it. I think most of us are more comfortable with this terminology. But we know we're not going to be able to isolate this. And so if you think back to the flow chart, I want to try to isolate it. If there's more than one variable, then I try to factor it. I can't factor this. And so then after that, I'm going to have to use one of those identities. And so I can tell pretty quickly that I'm going to have to use an identity on this in some way. All right? So what I'm going to do is I'm going to pretty much try to isolate this variable, even though I know I can't totally isolate it. Okay? You can pick either one you want. I just think this one's going to be easier. What I'm going to do is I'm going to add this inverse cosine x over to the other side. Okay? So if I was going to try to isolate this x, I would add the cosine x over, the inverse cosine x over, and so I'd have inverse sine of x equals inverse cosine of x plus pi over 6. Keep going with the isolation. If I'm still trying to isolate that variable, peeling the onion, I'd have to get rid of this inverse sine. And so we're going to end up taking sine of both sides. Gives me x equals sine of inverse cosine of x plus pi over 6. Now, I think what makes you understand this problem a little bit more is if you understand that this is an angle. Okay? So I'm gonna kind of call it theta, so it looks more like an angle. This looks like an angle to me. I've got sine theta plus pi over 6 x equals. What we did was kind of a substitution. We let theta equal inverse cosine of x. If you can understand that that inverse trig function is an angle, I think it's a lot more obvious what you're going to use next. We're going to go over here to the identities, and hopefully you recognize a sine sum. Sine a plus b, sine of angle plus angle. And so you have to recognize that this is a sine sum right here. And we're gonna transform this into that sine sum identity where it says sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. X equals n, of course. So we've done these in the past. Okay, we've done sine sums in the past, and what we have done is we've said that's 4 holes to fill in. And we're going to have to fill in those 4 holes. Now, some of those holes are easier to fill in than others. If you look at cosine pi over 6, we know what cosine pi over 6 is. Square root of 3 over 2. We also know sine pi over 6 is 1/2. Right? And so think back. It's been a while since we've done one of these, a couple of weeks maybe. But do you remember what we did to find those other holes? Make a triangle. Okay? We're going to end up having to draw a picture of this. We're going to draw a triangle. We're going to use Pythagorean theorem to find the missing side. We're going to look at those ratios of the sides to find those other 2 trig functions that are missing right now. Okay? And honestly, that's the hardest part of this problem. There's a lot of things about this problem that are kind of hard, but that's the hardest part. Okay? Because we don't know what quadrant to draw a picture in at this point. And so we have to figure it out. Now, I think that's the hardest thing to understand. And so I'm going to kind of skip over that. I'm going to go over that at the end because I want you to understand the main focus of the problem. And then we'll come back and I'll tell you why this is in the first quadrant. Okay? So let's just assume we know already that it's in the first quadrant. We're drawing a picture of theta. That's our angle, right? We're drawing a picture of theta. And you don't know this at this point, but we're kind of just guessing it's in the first quadrant. Okay? Draw a triangle representing that angle theta in the first quadrant. And so over here, when we're talking about this angle theta, we've got the cosine ratio. the cosine ratio is x, or x over 1. And so we've got the x side and the r side. That cosine ratio gives us x over r. And so we have two sides. As soon as we see this statement right here, we've got those two sides. And so we're going to do Pythagorean's theorem to find the missing side. Now, some of you might be able to do this in your head. Awesome. Most of you maybe can't. You do Pythagorean theorem here. X squared plus y squared equals 1 squared. Subtracting the x over, I'm trying to find the y side, so subtract that x squared over, and then y squared equals 1 minus x squared, because 1 squared equals 1. You're going to take the square root of both sides, and so that's plus or minus square root of 1 minus x squared. However, since we're upstairs in the first quadrant, that y has to be the positive value. So we know right now that y equals the square root of 1 minus x